Hi all, today's topic is the extraction of alkaline earth metals. Okay, before starting the extraction process, first we have to see from where these group 2 metals received the name of alkaline earth metals. The reason lies in the fact that the oxides of calcium, strontium and barium, they were not much earlier than the discovery of the metal. And people called them as alkaline earths because they were alkaline in nature and all of them were obtained in earth. Okay, they were obtained from earth and they were alkaline in nature. That's why they called them as alkaline earths, the oxides of these metals. And later on, when these metals were discovered, they named them as the metals which were present inside the alkaline earths. With that meaning, they called them as alkaline earth metals. Now let's see the extraction process one by one. First one is beryllium. The main source of beryllium is beryl and it's actually beryllium aluminum silicate. Okay, it's a silicate ore and it's a crude form of emerald. Okay, you can see that the color of this beryl is pure red, green in color. Okay, and then how this is extracted. First, this beryl is treated with sulfuric acid to convert beryllium and aluminum into their sulfates. See, here they exist as silicate in beryl and from there, these are converted into sulfates. Okay, first these are converted into sulfates and then this aluminum sulfate is removed from the system and the resulting beryllium sulfate is converted into beryllium oxide. Okay, and how this is done? This is calcinated. Calcination means just heating in presence of in abundance of air or oxygen. Okay, from there it is reduced to get pure beryllium. Okay, that oxygen is removed by some means in an electric furnace to get pure beryllium. Okay, let me repeat. First, these silicates are converted into sulfates and then aluminum sulfate is removed and then the beryllium sulfate is calcinated to give beryllium oxide and from this oxygen is removed in an electric furnace to get pure beryllium. And next one is magnesium. You can see the beautiful crystals of these minerals: magnesite, dolomite, asbestos and carnallite. These are the four main minerals of magnesium and this is extracted from magnesium chloride which is obtained from carnallite. Okay, in carnallite you can see magnesium chloride or from magnesium oxide which is obtained from magnesite. Actually magnesite is magnesium carbonate, but the magnesium carbonate is converted into magnesium oxide first and then from there magnesium is extracted. Okay, the easier way to understand will be from magnesium chloride because in all these processes the common pathway is the electrolysis of the chlorides. Okay, that we have seen in the case of alkaline metals also. Okay, next one is calcium. Calcium mainly exists on earth as carbonates and sulfates and there are a number of varieties of calcium carbonate and calcium sulfate available. Okay, we know that limestone is calcium carbonate, chalk is calcium carbonate, even marble is calcium carbonate, calcite is calcium carbonate. Okay, and there is no structural similarity between limestone and marble, but still both of them are the different forms of calcium carbonate. And gypsum, that is calcium sulfate, and there is another form of calcium sulfate which is called anhydrous. Okay, anhydrite, sorry. Okay, calcium carbonate in the form of limestone, chalk, etc., and sulfate as gypsum and anhydrite. Here, in the case of gypsum, there were two water molecules, and in anhydrite, that water molecules are not there. Okay, and the biological importance, okay, physiological importance is that it's an essential constant of bones and teeth as calcium phosphate. Okay, it's not pure calcium phosphate, but the main component is calcium phosphate. The structure is rather complex. And then the eggshells, all eggshells are made up of calcium carbonate. Then when it comes to extraction process, it is electrolyzed by the fused mixture of calcium chloride and calcium fluoride. Okay, one thing to be noted is that it is not extracted from calcium carbonate or calcium sulfate. The answer lies in the chapter, this metallurgy chapter. From there you will be knowing that in many cases the metal is not extracted from their minerals or ores. Instead, from there they are converting into something else or less available. The metal is maybe extracted from less available other compounds also. Here that happens in the case of calcium. It is not extracted from the abundant calcium carbonate or calcium sulfate. Instead, it is getting extracted from calcium chloride. That would be the feasible process. Okay, that's why they will be considering this by looking into their abundance, their processability, the low cost of processability, and okay, by considering all these facts, they have the cheapest way or the best method to extract this calcium is from calcium chloride. Okay, calcium fluoride is added to decrease the melting point, and this is electrolyzed in graphite vessel using iron cathode and graphite anode. Next comes strontium. Two minerals, important minerals, are celestine and strontianite. Celestine is strontium sulfate and strontianite is strontium carbonate. Okay, and here also metal is obtained from the electrolysis of strontium chloride. Okay, ammonium chloride is added to reduce the melting point, and it is electrolyzed using iron cathode and graphite anode, the same process as that of calcium. Now barium. Barium, the main ores are witherite, which is barium carbonate, and barite, which is barium sulfate. But the metal is extracted from barium chloride. Okay, here there is a difference. Mercury cathode is used. Okay, in the previous examples, iron cathode was used, but here mercury cathode is used. And after this electrolysis process, beryllium amalgam separates out. We are not getting pure barium. So, no, it's not beryllium, sorry. Barium. You are not getting pure barium, but you are getting an amalgam. Amalgam is a compound of the metal with mercury, right? So, barium amalgam separates out, and that can be easily avoided. I mean, separated by distillation. Okay, mercury volatilizes very much easily and by leaving behind pure barium metal. And the last one is radium. It is highly radioactive. Okay, it is very much radioactive. It occurs in minute quantities with all uranium minerals. The main uranium minerals in which radium is present to a greater extent are pitchblende and carnotite. Okay, these are the cheap sources of radium, and this is obtained by the electrolysis of fused radium chloride using platinum iridium anode and mercury cathode. Okay, this is a very much tedious process. You know that this radium is invented by, or it's discovered by Marie Curie and Pierre Curie, and they obtained this radium chloride from pitchblende. Okay, they have taken 5 tons of pitchblende to get only milligrams or even micrograms of radium chloride. And you can understand how difficult it was to extract this radium chloride from pitchblende. Okay, it took them years and 5 tons of pitchblende and their hard work and labor to get only milligrams of radium chloride. Okay, and the same pitchblende, they were together in their works, and they succeeded to separate another metal which is called polonium. Okay, in the beginning it was believed that pitchblende contains only uranium, but from the same pitchblende they extracted or they separated two highly radioactive elements which are radium and polonium. Okay, and here from this radium chloride it is electrolyzed using this much mercury cathode, the same process, and the radium amalgam separates out. It is distilled to get pure radium metal. Okay, this much is for extraction of alkaline earth metals. Thanks for watching.